In last class also, we have discussed about this same thing, modular programming. What we did was we just went through few slides and we just stopped. So basically, the first slide consists of the definition. That is, it is a technique which is used to divide a larger program into small, manageable, and functional modules. Now, what happens is when when we work in a project, then it's not that we build small programs over there. The program that we are building is a larger program. So for larger program, we will require more codes. Okay, more lines of codes are required. So in that case, what happens is, if we write down codes, all the codes in one place, then it will be very much difficult. And that's how we've been studying till class 9. Okay, so what happens is, suppose if you have a larger program with larger codes, larger number of codes, then what the best thing is, we divide that particular codes into small units, and those small units are known as modules. It is also known as blocks, or sometimes it is also known as sub it is also known as procedures. Okay, whatever name you give, some of them they even call it subroutine as well. So there are many names, and among these names you can follow anyone. Okay, whatever you feel comfortable with. And more often we'll be using this word, that is procedure or modules. Okay, so what we do is we divide codes into small units, which is known as modules or modules or procedures. So what happens is, once a code is divided into small units, we don't have to concentrate on the whole code. So we just concentrate on those modules. And the advantage in modular programming is, any unit or any module can be tested, or it can be any module can be tested independently. We can run any individual module so that we can check. Okay, and once all the modules are ready, then what we can do is we can combine all the modules, and once we are able to combine all the modules, then we get a software or a single program. And that program we said was the larger program, which we broke into different modules. Now, if we don't have this concept, that is modular programming, then what we have to do was we had to write everything in the same place. Okay, now when we use modular programming, those modules will be concentrated into different parts. Okay, it is not in the same place, but it is in a different place. That whenever we typed, and when I typed sub and wrote the name of the sub procedure, press enter, it took me to the another window. So that particular window is for the module, and there we wrote the codes that were required in that module. So in this way, what we can do is we can separate modules individually, and what happens is we can run module individually, we can edit, and we can do all sorts of work. And once all the modules are ready, then what we do is we combine or we integrate all the modules together, which gives us the required program. So that's how basically modular programming works, and it consists of two parts. One is known as the main module, now which we have already seen, that is, which consists of declare, which consists of calling of the sub procedure or the calling of the module, and after we call, we write down end. That is basically the main module. And after main module, we have another modules. Those are known as submodules. Okay, those are known as submodules, or even known as function modules. These are the actual modules that we are learning in modular programming. So module can be created in two ways. That is, one is with function procedure, another one is sub procedure. And whatever we have seen is all from the sub procedure. You either call it sub procedure or you call it sub module. It refers to the same thing. Okay, so being said all that, let's continue further with our slide, that is modules. So it is a block of statements that performs a particular task, and basically module consists of statements which does a particular task. So whenever in an example, what we have done was we saw an example of area of a rectangle. And in the submodule part, what we did was we wrote the formula as well as the print statement to display the area. So that's how we work with. Now, after this, we'll continue with another slide. Let's move towards, okay, there is one more thing which we have already said, that is modules can be created in two ways. One is sub procedure, another one is function procedure. And we are dealing right now with sub procedure. Okay. So advantages, basically there are a few advantages I've noted in the PowerPoint. The first advantage is different programmers can work in different modules independently. That is, what happens is a program, it will be divided into different modules, and each module is allocated to different programmers. So programmers, they don't have to worry about the whole program, but only worry about the module that they got. So what they will do is they will work on their specific modules independently. And once all the programmers are ready with their modules, then it gets integrated to get a main program. Okay, that's how modular programming is done. Okay, let's go towards another advantage. It is easy to design, code and test the program modules independently. Now this is kind of obvious, because instead of working in the entire program, if it is broken into different parts, then that particular part or the module which has been broken from the whole program will be definitely less. It will consist less code. So if it is less code, then it is easier to be coded, it is easier to be tested, it is easier to be debugged, and so on. So modular programming concept is easy to design code and test the program modules independently. Okay, now the third one. Now actually this is the main advantage. Okay, this particular point is the main advantage. And what it says is, once we create a module, okay, once we create a module, then what we can do is that module can be reused. Now every module will consist of a set of codes, and whenever we are ready with any module, then the codes that are present in that module can be reused. What I'm trying to say is, suppose somebody has created a module, and let's say it is module 1, and they are there, okay, and there is somebody who is writing the code. Now this module has already been created, and what it requires is the code that is present in that module, exactly the code that is present in this particular module. If it is required in somebody else's work, then what he or she can do is, you can, it's not necessary to write everything that is in this module, but what you can do is we can use this module and keep it in our program, so that the codes that are present in this module are reused. Okay, so this line means that whatever module that has been created, all the codes that are present in this module can be reused. And once we do this, then what we are doing is we are reducing the program code. Now suppose if this module code has to be written over here, then it is simply the duplicate of whatever is here. So instead of copying everything, what we do is we simply call this module from this part, so that this code gets executed, so that we don't have to write this code again. So this basically helps in code duplication. Now let's move towards another slide, which is sub-procedure. So sub-procedure and function procedure, whatever you say, the definitions will always be the same, because both of them, they do the same work, but there is a slight difference which will come in the second point. So the first point says sub-procedure, it is a small logical and manageable functional part of the program which performs a specific task. Now small logical manageable functional part means it will consist of certain lines of codes, and that line of codes does a specific task. Okay, that is basically the meaning of this particular definition. And secondly, this is quite important, that sub procedure, it will not return any value. And for now, what you have to do is you just need to simply remember this line, that is sub procedure does not return any value, because this part will be clarified when we reach function. So for now, just remember this. Okay, parameters or formal parameters, that we have already seen while we were coding a program as well. So parameters or formal parameters is refers to the same thing, and it is the variables that receives values that are sent by the procedures whenever a procedure is called. Whenever a procedure is called, certain values are sent, and those values are stored in a variable, and those variables are said to be parameters. And parameters are also known as formal parameters. Now let's move towards another slide. Okay, it's a, okay, no, nothing new in this line. Okay, another is arguments. So arguments are also known as real or actual parameters, and the definition is arguments are actually the values that are sent to the procedures, and whatever values are sent or whatever arguments are sent, those are stored in parameters. Okay, it's the so arguments are values that get stored in parameters, and parameters are the variables that stores arguments. Okay, this is how you can remember. Okay, now in order to work with sub procedure or any module, what we do is we do three things. One is declaration, another one is calling of a sub procedure, and third one is writing down the definition of a sub procedure. Okay, so declaration, we do it like this: declare, then we write down sub, then we write down the name of the sub procedure, then we write down the parameters. If there are any parameters, we write it down, or else we just ignore it. So this is just the definition. And okay, one example, if we want to write down the program for area, then this is how we write declare, we write sub, then we write down the name of the sub procedure, and this LB over here is the parameters. Okay, now basically how we can identify is, suppose if we are taking input from the user, then what we expect is certain values that will be typed by the user. In such cases, what we do is we write down the parameters, and these parameters are usually for the inputs that are being typed by the user. Suppose user types, in this particular program, user will type two numbers, that is for length and for breadth. So in order to store those values, we are writing LB, L for length and B for breadth. So this we have already explained, and we'll see in a program as well. So let's move towards the next slide, which is calling of a sub procedure. So first is declaration, then it is calling, which is done like this. So basically we'll be using a call keyword to call a sub procedure, and it is done like this. That is, we write down call, then we write down the name of the sub procedure, then we write down arguments. If there are any values, if there are parameters, then obviously there will be arguments, and whatever arguments we sent while calling, those arguments will get stored in the parameters. So okay, there is nothing new over here. Okay, here is an example that it says states, we write down call, and previously in declaration part we had written area as the name of the sub procedure. So same thing, call, area, and LB. Here LB are the values, okay, length and breadth values, and these values will be stored in the L and B variables given in the declaration part or the definition part. So in order to define, we start with sub, we write down the name of the sub procedure, and we write down parameters. Actually, this is not arguments, but this is parameters. Okay, last time also, in last class also, it was the same. I told you that this is not arguments, this parameters. Okay, okay, I'll correct this one. Okay, so after this, let's move towards here. Okay, so subprocedure arguments. If there are any arguments, we write it down. Sorry, this is parameters actually. So parameters, whatever values are sent in the form of arguments for while calling, those values or arguments will be stored in parameters. So it is sub area, name of the subprocedure, and the parameters L comma B, and we write down the body, then we write end sub. So this is how we define. So now let's go towards our actual program. Okay, let's go towards our actual program and let's see how this thing works. Okay, so the first question that we'll solve is the revision. Well, is the revision part, and the revision, and in revision what we'll do is we'll do the same old program which is related with area of a rectangle. So the question is, write a program to input length and breadth of a rectangle and display its area. Now every program has to be done using subprocedure or function procedure. Okay, so we have only studied function procedure, so it is using a subprocedure. So this is what we have studied. So this is the question. Now while writing in your copy, you don't have to write this single apostrophe sign. Now that is actually for remarks, or you can even write rem, remarks, no problem. But in copy, you don't have to write this rem. Now this is simply the remarks statement, and remarks statements doesn't get executed. Okay, so now please don't busy yourself copying everything, because this thing I've recorded this and I'll keep this link in the Google Classroom. From there you can open the video and you can write down. So for now, just try to understand whatever is being said. Okay, so the first part is declare. So let's start with declaration. That is declare sub, then write down area, then write down L comma B. Okay, then after declaration, what we do is we write down CLS. Now CLS is basically to clear the output screen. That's it. So after we clear our output screen, what we do is we write down input keyword for length and breadth, because we have to take two inputs. One is length, another one is breadth. Okay, we have to take two inputs, length, breadth, and for length, breadth, we are writing two input. And one more thing, please pay attention that whenever you are using input, write down each input in a separate line. Don't write down everything in the same line, like enter, length, and breadth. Don't do like this. Okay, now we can take input like this, but don't do like this. Okay, for single input, write it in a separate line. Now this is how things are done in SE. So let's follow the same thing. Okay, now let's take input for breadth. That is enter, breadth, enter breadth, and for breadth let's give variable b. Now whatever values user types, those values will be stored in length and breadth, and length and breadth are actually values that will be stored over there. So now what we can do is we can call. So call, write down the name of the subprocedure, and the name of the subprocedure is area, and we have to write down the arguments, and the arguments are the values, and the values are stored in this L and B. So we write down those variables over here, L comma B, and L comma B are the values that are being sent to the subprocedure, and we write down end. So this is basically the sequence, and this is known as the main module. Whatever we have written from declare, to the end, is, from declare to the end is the main module. Now we'll go and write down the definition for the submodule. So far we have done two things over here. One is declaration, another one is calling. Now the third part is definition, and definition is written below end. Sub area, and as soon as, now this sub procedure consists of parameters, so we have to write down parameters, which is L comma B. So this L comma B is the formal parameters, whereas this L comma B is the real or actual parameters, which is also known as the argument, and this is also known as, simply known as, parameters. So as soon as I press enter, now this is the sub procedure or the module that I'm trying to create. So as soon as I press enter, this module will be directed towards a separate window, as you can see over here. And from here, what we'll do is we'll write down the body for the area sub procedure. So whatever is required, we'll write down over here. And the first thing that we need to do is write down the formula, that is A is equals to length into breadth. So I'm trying to store area in the variable A. You can write AR, but you cannot write area. This also we have already seen, because name of the sub procedure has to be unique. It should not be the name for the variable. Variable names cannot be the names that we have used for the sub procedure. So I'm writing a separate name and simply A. You can write AR, you can write ARE, but you cannot write ARE. Okay, so area has been calculated and stored in variable A. Now what we need to do is we need to print the value for the area, which is in A. So to print anything, we use print keyword. Let's write down one line, that is the area of a sub, okay, sorry, the area of a rectangle is, it is stored in A. So let's run our program. Enter length 5, enter breadth 7. So 7 5 or 35 is the area. So this is the program to find out the area. Now let's move towards another question, and our another question is related with perimeter. So let's do, write a program to input length and breadth of a rectangle and display its perimeter. So we'll be doing few formula programs to get familiar with sub procedure. After this, we will be moving towards few conversion programs, and then we will move towards function, and through function also we'll be doing the same programs. Okay, so after we finish everything, then we'll move towards if statement programs. So okay, I've already written the question. It says display the perimeter using sub procedure, as you can see the question. Okay, so for perimeter, what I'll do is I'll write down, I'll change the sub procedure, which is perimeter. So the best thing is you give appropriate name for each question. Now this question is related to perimeter, so the best thing is you give the sub procedure name as perimeter. Okay, so okay, we have 10 more minutes, people. So after, so please stay. Now I'll just do a few programs. Okay, now this will finish in a while. So for perimeter also we need length and breadth. So length and breadth is already there. So what we need to do is, after taking input, we have to call the sub procedure, which is perimeter this time. And after we have called our sub procedure, we write down end. Now let's move towards our sub module or the sub procedure, which is over here. Now here the name is different, area. So let's change area to perimeter. Okay, now in the body part, what we are trying to do is we are trying to calculate perimeter, but over here there is area. So let's erase this one, right? Perimeter. For perimeter, I'm simply using P equals to 2 multiplied with length plus breadth. So length is in L, breadth is in B. So this is the formula. And once the perimeter is ready, what we need to do is we need to print it. So in order to print, we are using print keyword. We are using print keyword, the perimeter, P. So the perimeter of a rectangle is not A, but it is P. So let's run our program. Let's give the values 4, 6. So 6 plus 4 is 10, 2 are 20. So 20 is the perimeter. So basically this is how we write down the formula programs. Okay, now so far all the programs that we have written consists of only one module or one sub procedure. You can see over here. This untitled is the main module. Okay, untitled is the main module, and if we want to go inside our definition or the sub module, then we have to select the sub module, which is perimeter. So if I enter if I press enter right now, then I'll be directed towards the sub procedure. So I'm pressing enter, so I'm directed towards my sub procedure. Okay, this is how you can navigate between your main module and your sub module. So okay, what I was saying was, so far we have written two programs. In both the programs we just had only one sub module. Now it is not true that you in a program you can only have one sub module. You can have as many sub modules as you want. So here is one example which will show you two sub modules, and we are not going any further from that. Okay, and the question is, write a program to input. Okay, the question, okay, write a program to input radius, that is DIUS. Okay, radius of a circle, and write a program to input radius of a circle and display its area, and circumference. So in this case, what we have to do is we have to use two formulas, one formula to calculate area and another formula to calculate circumference. So in this kind of questions, or in this kind of case, what we have to do is we have to create two sub procedures, and sub procedures are created in this way. Okay, so declare sub. So let's create sub procedure for area, that is area. Declare sub area, and since this question is related with circle, we just need one input, that is radius. So let's keep R, and we even need circumference over here. So declare sub circumference, and for circumference also we need one value, and that value is for area. So what we'll do is we'll take one value, that is radius, as an input. So enter radius, DIUS. For radius, write R, and that's only the input that we need. Now what we'll do is we have to call the sub procedures, and in this case we have two sub procedures. So we'll be using call keyword twice. First, we'll be using it to call area. So pass value R, and secondly we also need circumference, so we need to call it as well. So circumference, right R. So we have used two sub modules, and the first one, that is area sub module, will calculate area and display area, and the second sub module, that is circumference, will calculate circumference of a circle and display circumference. So okay, let's write down the definition. Sub area, and this particular definition will display area. So press enter. I'm directed towards area submodule. Now let's apply the formula, that is A is equals to pi r square. Now pi is the value, and the value of pi is 22 divided by 7. Now if you know this, then you can even write 3.124 and so on. Okay, but the preferable one is 22 by 7, because we don't get the exact value for 22 by 7. So it's better you simply write down 22 by 7, and calculation and everything will be done by QBASIC editor. So we don't need to worry anything about that one. So pi r square. So pi multiply r square. So r square, you can write r into r, or you can even write r exponentiation 2, and this is r square, this is r square. and it's better you use this brackets, or if you ignore brackets also, it should work in a correct way. But if you give brackets, then it's safe, because first of all we need to square, then we are multiplying with the value of 22 by 7. And instead of 22 by 7, you can even write 3.124 and so on. No problem. Okay. So after calculating area, let's print it as well. The area of a circle is, we have stored it in A, so let's write down A. So this is the statement. Now this is, so far what we have done is we have only made sub procedure for area and calculated area and displayed it. But for circumference, we haven't done anything. So what we have to do is we have to create one more module for circumference. So let's go towards our this main module, and what we'll do is we'll write down the definition. So write down definition using sub, then write down circumference, then write down R. Now here we'll write down the definition for circumference. That is a formula. C is equals to pi r square. Pi is 22 divided by 7. Okay, no, it is 2 pi r. Sorry, 2 pi r means 2 multiply with pi, that this is pi. Okay, 2 pi, now r, multiply r. So this is the definition, 2 pi r, 2 multiplied with pi, multiply with r. Now simply the only thing left is the circumference of the circle is C. So this is what we have, this is the variable that we have used. So let's run our program. Before running our program, there is one thing extra. This is not required right now. So if you do not need any sub procedures that you have created, so you can simply delete it. Select the sub procedure that you want to delete and press this delete procedure. Okay, so we are left with area and circumference. So let's run our program. So radius, okay, radius, I am giving radius as 7. So here is my area and here is the circumference. So this is how we can solve our program. So in this session we have done 2 to 3 programs. Okay, and this I will keep the link and you can write down the programs from the video.
Thank you so much for watching. Please do like my video so that I get motivated to create more of these videos. We would appreciate if you would share this video with your friends. And if you have any queries and suggestions, let me know through the comment section. Lastly, please do subscribe my channel and press the bell icon so that you get notified every time I post a new video. Thank you.